Hello, everyone. Good afternoon or good morning, depending on where you are. I'm Gerhard Goldbeck. I'm pleased to chair this session. I'm really excited about the session today that we have gathered. Also, to say hello from Alex Simperle, who has organized a lot of what we're doing today. Unfortunately, for personal reasons, can't be in the session today, but we'll also be recording this, so for everyone who share this, be able to join in at a later stage. So I think we are, yeah, you can see the screen, everything, you can hear me.
Yeah.
Okay, so so this is the session on education and training. We have a bit of background noise at the moment, but hopefully that'll go away. I'll just say a few words, to introduce what we are talking about, what we want to discuss with you today. Now, we seem to be in the right mode and hopefully mood as well. So this one?
Just press here.
Yeah. So the session speakers, and I'm really very happy to have all of you here is and online. First of all, it will be Florina Piroy and Umuchan Celis from TU Wien and STI's Innsbruck, respectively, about computer science training education in the Alpine region. Then we have Henrietta Hamse from EMBL EBI about the experience in teaching researchers to construct their first ontology. Nicole Wasilewski from the Critical Path Institute, Tucson, Arizona, but I think joining us from Portland, Oregon. I think you can tell us in a minute about the OBO Academy, training materials for bio-ontologists, and Claire Johnson, who is a training coordinator at SciByte, about unleashing software superheroes in industry, training professionals in ontology management. So really fantastic program. It's just a little bit of the background. In the OntoCommons roadmap, and there was a session also on that yesterday, we identified industrial needs that are, of course, related to turning the semantic technologies into business benefits, requiring best practice to do that, requiring advice, requiring skills and capabilities, and really to help. And the human factor here is very important to reduce uncertainty and risk of investing into semantic technologies. One of the things that we've already been doing in the OntoCommons project specifically, and contributing to that, is define the concept of what we call the translator in knowledge management for innovation. There was a collaborative effort on a white paper where this role has been defined. This is really to bridge the gap between the semantic data scientists, ontologists, and then the industrial requirements and users of, and hopefully beneficiaries of that technology. We also had some online sessions to identify, what are the training and professional development requirements to enable that role, that sort of intermediary role, but of course also what we want to discuss here more widely is the whole landscape of training and professional development in these technologies and in this connection between the people that have really done this for years as professional development and those that are new to it. What is the status of the skills in education in semantic technologies? What are the needs of industry regarding skills? What is the landscape of available training and professional development resources? What are the experiences regarding education, training, and upskilling, and what are considered to be best practices? And I'm sure we're going to get a lot of input and hopefully some answers in the session today from our speakers. So I'd like first to ask to the floor Florina Piroy from TU Wien.
Everyone, and welcome to this afternoon session. I'm going to show you some examples from our university where I've been directly involved in educating across domains. And I think this is a very important topic because we've seen it OntoCommons and also other projects on the trans, that you actually need people who understand the adversary, let's say like that, the opposing party, the collaborators in a project who are differently trained than this. So I am working at TU Wien in Austria. And the motto of our university is technology for the people. And this is just a couple of PR slides. It's the largest technical institution in Austria. It has 8 faculties, about 50 institutes in these domains. We have over 4,000 academics. So these are now teaching and researchers staff, 26,000 students, quite a lot of them international, at least about a third come from outside Austria, and we have 57 courses of study. Split by number of students, we have most of them in informatics and business informatics, and then architecture, and then they go lower and lower to the geodesy and geoinformatics. Where do the alumni go from our university? This is now information extremely difficult to obtain, but basically they go to Siemens, they go to ÖBB, this is the Austrian railroad company, working in logistics or information technology engineering. Now, about cross-disciplinarity, because we recognize that this is something absolutely necessary, especially in our faculty where we did lots of projects with industry, and we realized industry half the time didn't really understand what we are saying, and when they understood, they also didn't understood correctly. So one of the first projects I was involved in was called an Innovationslehrgang, Data Science and Deep Learning, and the idea for this was that we need to train the practitioners, the ones who are already programmers and working in companies, in the new stuff, in the data science technologies, in the deep learning. Why? Also, why this project? Because at that time, our university also started a new curricula in data science, but from the point where these students start studying data science until they really get to apply it correctly in their companies, there is a gap of about 4 or 5 years, and we wanted to cover this gap with this project, with this lecture series for the ones who are already in the industry. So we had 5 pretty large modules on data science. The IT specialists came from all these industries. We had lots of very interesting chats about this or that problems they have there. And the lectures were really broad, from data science, machine learning, visualization, semantic methods, and we had also a module on ethics. It ended 2020. Now about this master study, data science, which is at the Faculty of Informatics, at the research unit at the institute where I'm also affiliated with, has these 5 big chunks of lectures, these pillars. The students are taught data science foundations, domain-specific aspects of data science, machine learning, statistics, high-performance computing, because you get to work with big computing clusters, and they are also taught analytics, visual analytics, semantics, technologies, and of course there are a lot of elective lectures at the end. And you notice there this red entry there, domain-specific aspects of data science. This is a very important module in this master study. And if you look on our curricula website, and we have an internal website at the WIN where all the lectures are listed, how many ECTS, how many hours per week, and so on and so forth. And you see this interdisciplinary lecture series on data science. What happens there? And this is a mandatory lectures. The students, who are about 200, 250, 300, depending on the year, but we started with 100 students, now we are about 300. This is a mandatory lecture, and they have to sit there. And we have a lot of invited lecturers from other faculties at our university, and not only from other faculties, but also from other institutions and other universities. So we have some collaborations with the University of Vienna or with the Center for Weather Control, Weather Prediction in Vienna. And these people come and they present their challenges with data in their domains. For example, this is now the list of lecturers we had in the first iteration, 2018. So we have people from the Faculty of Physics, from the chemistry. We even had somebody from the University of Vienna who was handling Facebook data for social analysis. And people working with in IT, in information technology, where they were monitoring network packages, so TCP/IP protocols, really monitoring very low-level internet traffic. So the students, they are exposed to all these problems. Computer science students, they are exposed to all these problems. And after that, poor students, not only they have to complete this lecture, but they also have to finish and to do a project, an interdisciplinary project, where they choose one of these lecturers, or maybe another one if they know somebody else, and then they have to go with a talk to that person, understand their challenge, and start a data science project with that person. Not only that, but they also have to take one very basic lecture in that faculty, in that university, in that domain. So if I'm choosing to do anything with geospatial data, because I want to manage, I want to process images, Earth images from the satellites, then I cannot just apply whatever machine learning algorithm. I really need to understand what's happening. So I have also to take a lecture in Earth imaging and other basic stuff there. So at least one lecture. And they are pretty intense, what you call, time-wise. So that is the data science lecture. And furthermore, what we are doing now, we are extending our reach to research data management. And we are planning now a new complementary study, which is now not only for computer scientists, but for everybody at our university. And we want to teach about the data lifecycle, FAIR principles, and preservation. And these look like very broad concepts, but when we teach about preservation and versioning and data citations, there we go and teach semantic technologies. We teach linked data. We will teach ontologies, because these are all used for data documentation, and they need that as well. Or FAIR principles, how to make your data visible. Again, we teach computer science aspects that fill in all these things. And we start now in October with a pilot lecture. We are heavily planning it right now. Let's see how this will work. And of course, we do teaching by doing, because we have in our research unit lots of projects with industry, with Siemens, with ÖBB, with I don't know who, where we work with ontologies, with data, and we just bring in the results from our work and standards and how to work with data to the industry. So that was it. Thank you for your attention, and ready for the discussion.
Thank you very much, Florina. And I think we hand over straight over to Umut for the next presentation. Without further ado.
Thank you. All right. Hello, everybody. I think all the bored from my face since yesterday, but here I'm again. My name is Umut Canzerles. So, you missed me, Dimitris. Thank you. So today I'm actually here. I'm wearing my hat of an educator, and I also like to tell you about how we educate computer scientists, particularly in the context of knowledge engineering and what we do in OntoCommons, basically. I am from University of Innsbruck, and University of Innsbruck is almost as big as, well, slightly even bigger than TU, apparently. The difference is we are not technical university. We have a lot of also other non-technical departments. And it's, if I'm not mistaken, is the biggest one on the Western Austria. And as you see, more than half of our students are international. And what is hidden here, the large part of this is the German students who want to snowboard for their entire studies. And a great portion of these EU students are from Germany and Southern Tyrol, so northern Italy. But at the end, yeah, we also train a lot of people from the entire EU. And we have 53%, more than 50% also percentage of women students, which is also, I would say, a good thing to have. Now let's come one level lower or smaller department, the computer science department in University of Innsbruck. We have actually two things that are related to this. One is the business informatics studies. So this is basically a lightweight computer science education supported with a lot of business courses. But there are some courses from this business informatics department. So there are some courses in the computer science department also offered to the business informatics students. And this is a fully complete master's program. We have about 190 students there, and we have 1,058 computer science students. And one of the questions actually Alex asked me when we were discussing what to present. So what do the students do? Yeah. And if you look at the numbers here, so the computer science department is part of the Faculty of Mathematics, Physics, and Computer Science. So we have actually here computer science, physics, and mathematics in this faculty. And 54% of the bachelor students are computer science students in this faculty. And as we go towards the PhD, this number goes down. So this is actually an indication that many computer science students go to industry and don't really even try to get a master. These numbers are way more closer to each other, even increase if you look at physics, for example, and mathematics. So industry is not a big option for them, I guess, currently, as much as computer science students. And so this is what happens from the education front to the students. Still, quite a lot of them do masters, but not many of them go to PhD. I also experience this from the first hand that it's incredibly hard to find PhD students that coming from the University of Innsbruck, basically, for our research group. Speaking of our research group, I'm part of the Semantic Technology Institute Innsbruck. This was a separate institute until 2017. Then it became part of the computer science department also. And yeah, so this is the core basic academic stuff. You see there, me, some PhD students from our department also, and our boss, Dieter Fenzel, is there. What we offer is 5 courses around what we do about what we do in the OntoCommons project, basically. And unfortunately, we don't have a master's study track as Fiorina has in the TU Wien that is only about data science. We have a separate one about software engineering and a classical master studies for computer science. Therefore, all of these courses are elective courses. So students actually have zero contact with these topics until they come to the master's degree. So this is something to keep in mind until the end of the presentation, where I want to also give some takeaways. Although we do offer quite many courses, so I go a little bit more in detail about them. So what you see is VU is a German term, acronym for Vorlesung mit Übung, which means like a lecture with exercise. And SE is a seminar. Yeah? And these seminars are research seminars technically, but we also use them as kind of abuse them to give students more practical projects. And first thing we did actually with our new offerings, we split semantic web and knowledge graphs. because from my experience or observation from many universities, this split is not really done. But I think there is an important split there. It was actually also for us an experiment to see if we could actually split those things. And we realized, so knowledge graphs, it's more about data management and, well, at the end, of course, in a lightweight manner, knowledge management. And semantic web is also because of historical reasons. It's about, there's a component of web, so the distributed component of it. And also, since the semantic web stack is so well established and has its roots from the knowledge representation community, you need to also be more involved with things like description logic, etc. So at the end, what we did was to have teach in knowledge graphs basically how to create, host, and curate a knowledge graph, like data quality, enrichment, cleaning, etc. So there, they don't really even learn OWL there. They don't also learn how Sparkle algebra works, but they learn how to write Sparkle queries and what a Sparkle query would return if they run on a knowledge graph. And semantic web, it's a little bit more theoretical, and there's also the web component. What is also more important for us, since the students don't have any contact until masters with these topics, we thought, okay, we should actually show them the value of these things in real life. Yeah? So it's not something they take theoretical because it was the only elective course they could take because in their schedule, or because it was the only English language course was offered in the university for them. But we want them to actually see the value of this. So what we particularly did with the seminars there is to do real life projects. Yeah? And what I mean by real life is actually either coming from that uses real data, that is coming from our spin-off companies, for example, and solve their real problems, for instance, or we solve wasting taxpayer money issues. So maybe you have seen in the news at some point, there was this thing called the Kaufhaus Österreich, which was basically an answer to the Austrian government. How do we help small businesses during COVID, right? They were closed and they wanted to implement basically e-commerce platform where small businesses would sell their products. And the problem was, well, small businesses don't have IT departments. Small businesses don't even have e-commerce systems. And even if they have e-commerce systems, these are isolated things. So at the end, what they ended up with is a €1 million worth of a Yellow Pages website where they had a web form where businesses actually were registering their addresses and some keywords about their products. And you couldn't even actually look for the product itself. So you couldn't look for a specific book, but you could maybe look for some bookstores. Yeah, this was basically at the end. And this thing costed €1 million. And we gave a project in our last version of our seminar where students actually implemented this thing in one semester by just crawling the web pages of the businesses in Tyrol, which was 60,000 web pages. And almost all of them had schema.org annotations. Some had more, some had less, but almost all of them had schema.org annotations. And they were actually able to build a platform, an aggregation platform based on semantic technologies, semantic that is cheaper than this and also way better, very functional than this Kaufhaus Austria. So this kind of example projects we try to give the students to actually show the value, how semantic technologies can help us in real life. I think this is much more valuable than giving them exercises about description logic. So particularly if we want to raise people who will carry their knowledge to the industry and also contribute to the economy later. Yes. So what the graduates do, this is not our university, this is entire Austria. So the Austrian students who graduated from technical information and technical departments of universities in Austria. This is from the Statistical Institution of Austria, basically. And as you see, many of them actually go to manufacturing, not as knowledge engineers probably, but more software developers, I would say. And another large portion work as freelance or as consultant there. And another large portion also goes to telecommunication companies like, for example, A1 or Deutsche Telekom, this kind of thing. So they also go such companies. And also the fourth biggest portion would be then the education track. We also, from our group, we offer students positions for part-time researchers. We basically raise them for our spin-off company and also as PhD students as much as possible. But as I said, it's not very easy to do this. And from an OntoCommons perspective, we also use the examples that I've seen here, for example, in terms of domain ontology landscape as examples, and also invite some guests from our project, particularly from our demonstrators, to explain how semantic technologies are used in industrial use cases. For example, we did a guest lecture like this with Evgeny 2 years ago. So last slide, what I learned from OntoCommons as an educator. What I learned was you should not need people with PhDs to develop applications with semantic technologies. I think this is not a very cost-effective way to handle this. And if you remember what I mentioned, that people don't have any contact, at least in our university, until master's level with any of the knowledge engineering stuff, any of the semantic technologies. And yeah, and this is also not very ideal, because until they come there, so everybody knows how to deal with databases, and also they have a mindset to work with databases, and this is not always very productive when you work with ontologies, because of the discrepancy between the closed world and open world, etc. And this makes it quite hard for us to also change their mindset a little bit, or not change, but give them a new mindset to handle, to deal with ontologies, for example. And they also already usually set up with their part-time jobs and their life. They have their ideas. So they don't even consider until then a career in this area. And what we also do, this is also maybe fault of the stacking of the semantic web stuff so far, the entire complexity is given in one lecture or in one semester. And this is also probably not the best way to handle this. We should spread the complexity across different levels of education and have layers of knowledge transfer between people with different qualifications, right? So the people with PhD should not be developing software, but they should be helping the people who are developing software when they get stuck. And between these different layers of qualifications, there must be some sort of transition, some sort of, let's say, knowledge osmosis that allows us to do this in a more scalable and cost-effective way. That's it. Thank you very much.
Thank you very much. Thank you for this stimulating remarks as well at the end. We are going to take, as usual in the sessions here at the conference, we're taking questions and discussions at the end. So we will now come to our next speaker, which is Henriette. Henriette Harmsen.
Yes, I'll be sharing my screen.
Do introduce yourself as well. I'll leave everything over to you. Thank you.
Hello, can you all hear me?
It works, and we see the slides.
Okay, thank you. Okay, so I'm Henriette Harmsen. I am the Ontology Tools project lead at EBI. I've got a background in computer science, and I don't know much about biology. And in this session, what I'll talk to you about is a project that we worked on with EOSC Life with regards to phytoliths. And so I first will tell you what a phytolith is, then I'll tell you a bit about the problems that they have in this research area, and then I will tell you about our challenges in training people to create their first ontology. So first off, what is a phytolith? So phytoliths are some silica that gets deposited by some plants, and these deposits can persist even after the plant has died, and even for years afterwards. And this is used by archaeologists to be able to, in at least certain circumstances, be able to identify the plants that's been of economic importance for some period of time. On the right-hand side, you can see some photographs of a spheroid phytolith. These phytoliths, typically where they find them is sort of around the dwellings, and they will find it in the gardens, in food, like the cutlery that they've used, the containers, and also in teeth, apparently. So what is the challenges around phytoliths? So phytoliths research really starts from late about 1850, but from the 1960s, various areas around the world has started doing phytoliths research. The problem is these research pockets sort of happened in isolation. So each of these research areas or regions actually ended up creating their own terminology, their own analysis and ways for reviewing phytoliths. So there's some inconsistency across various regions. And there's also some challenges there on the right-hand side. What I've showed is with regards to how people share data with regards to phytoliths, only about 4% of the data in publications is reusable. About only 70%, 79% also provide photographs for their phytoliths. So very often the phytoliths are being identified using photographs. And then not all the publications would necessarily share the exact methods in which the phytoliths has been identified and analyzed. A next problem that I have is that each phytolith could have various different names that it's referred to in the publication literature. So on the left-hand side here, we have one phytolith, and there's about 50 different names by which this has been referred to. That's shown on the right-hand side. Now, there has been some efforts to create standardization. So in 2005 and in 2019, nomenclatures have been published to try and address this. And what these nomenclatures does is to say, okay, this is the way you can name them. So they give guidelines as to how to name phytoliths. And then they also give guidelines as to how to describe them and how you have to sort of images that you can use to identify phytoliths. But still, in this research paper that I referred to, and sorry, I actually didn't say, this is a research paper that's been done by Emma Caroon. And in this research paper, it also actually states that these nomenclatures are actually not being used consistently in publications. So less than 50% of the publications actually use these nomenclatures. Then they have the problem of multiplicity and redundancy. Multiplicity is where different phytoliths can be produced by the same plant, and redundancy is where different plants can produce the same phytolith. So these are the challenges that they sit with in phytoliths. So the phytolith project has been started, and that is how I got involved in this. So this has been started as part of the European Open Science Cloud project for life sciences. And in that, Celine Gerfand approached me to try and help them to start to create their own ontology so they can start this process towards verification of and opening up the phytolith research. So this project of theirs, it's doing, they've done like a fair assessment to get a status of their current phytolith research, but then I also focus on building the community and then also providing guidelines for data sets and how that should be annotated. Now, the first problem when we started with the ontology is that it's a problem if you know that this is all the problems that you have to deal with, it can be slightly overwhelming to decide how to start or where to start. And this decision that we made was to try and find the smallest little thing that would add value, but that will allow the domain experts to actually get exposure to ontologies and build up their knowledge about ontologies. But then also, secondly, that will also help me to get an understanding of what the phytolith is and what is it that they're trying to achieve here. So it's a sort of a stepping stone for both sides, the domains expert side and the ontology development side, or the ontologist side. And the part that we decided on is what they struggle with is these large amounts of synonyms that's associated with each phytolith. So our first version of the ontology really just created the ontology of the phytoliths. And for each phytolith, it basically stated the synonym for the various synonyms for the phytolith, as well as the citation that's associated with that phytolith. And at this stage, this is an incredibly modest starting point, in that they only really have 22 phytoliths, which have over 350 different synonyms. Then the second problem that we encountered was when they now started to build the ontology themselves, was to the learning curve. So these are archaeologists. These are all PhD level people, quite knowledgeable about their area. But to get into ontologies and sort of a software engineering process is something that's new to them. So when I started with them, my thinking was based on the experiences at with building ontologies at EBI, and also like from the OBO community. There's some good guidelines in that regard, and typical tools that they end up using in this in these contexts is GitHub for version control, the ODK that is so helpful in firstly ensuring that everyone builds off the basic formal ontology as an opera ontology, ensuring that all your imports are kept up to date as part of your ontology release process, and then also the potential for having a quality control step as part of your ontology release process. And then the idea is to eventually make this available via our ontology lookup service, so that that could have a programmatic access and could allow people to annotate their phytoliths in that way. But then also tools that part of this is ODK also incorporates the robot ontology tool, which we intended to use for creating a template and generating the ontology from that. And then also Protégé, that's widely used for just editing ontologies. And Docker is supported by or used by the ODK. And if you want to run your own instance of the ontology lookup service, you can also do that via Docker. So when I started this training with these three archaeologists, this failed spectacularly. And the reason it failed so spectacularly is that tools like the ODK, Robot, and OLS actually require that you make use of the command line. And even though these people are extremely knowledgeable about like basic or computer literacy, they're completely computer literate, but they're not developers, they're not bioinformaticians. And that made it difficult. So using the command line was not something that came easy to them. Also, they ended up having different operating systems that they used for on their computers, and this was also done remotely. So one person was located in Spain, two were in the UK, but then this was all done remotely as well. So this added a lot of complexity, and this was a complete failure, actually. But then based on that, what we decided is, instead of me trying to teach three people at once, because part of it being remote, I don't see what they're doing on their screens. So I need to share, give them allow them every now and again to be able to share the screen and change that this person share the screen, then that person share the screen, and it just been very time consuming. So instead, I ended up teaching one person, but what I also did was I revisited the tools that we're going to use and really start with the bare minimum to begin with. And for that reason, we basically started with the Git and robot and Protege. So Git is still for the version control, so that's why we kept that. Robot we kept because to create an ontology in Protege also actually requires quite a skill level, and most people are more familiar with spreadsheets. So started with the spreadsheet approach and allow them to fill in particularly what they were interested in was this being able to specify their synonyms. So there's the synonym, and so they could have many synonyms, which doesn't scale well for the spreadsheet. So if we have this situation where you have one phytolith that has 50 synonyms, having this in a spreadsheet will become cumbersome. So what we've done is to allow them to add, like, I can't recall, but I think something like 5 or 10 synonyms, and then any other synonyms they have to add directly into Protege. And I taught one person how to do that, and that actually worked out quite well. So then the other part of it is, of course, is to remember the community. And that is where I think they've started the International Committee on Open Phytolith Science. And through this committee, they've arranged numerous workshops to also train the community, because in this community, they're not really that knowledgeable about ontologies, and to actually start to expose them to the potential value that ontologies can bring to them, and how this can bring this different research and the different regions together. So really in that regard, I think the ICOPS have done an excellent job. Then just to state, this is the little part that we've done. So we know we're very early in days. So I think if I was to do this in a year or maybe 2 years later, I will come with a whole lot of more things that we'll learn and mistakes that we've made. So this is still early in the journey. And then also I want to thank the ICOPS for actually inviting me and allowing me to be part of this process. Before this, I didn't know what a phytolith is, and this exposed me to a whole new world that I absolutely knew nothing about. So I really love to be part of this process. That's all from me. Thank you.
So I just thank you again for your presentation and for showing that journey, which is really going to be really interesting for us also. I have some questions about that, but maybe later. But because first let's go through the presentations. Thank you again. For that, the next speaker is Nicole Wasilewski. Nicole, are you there? And yeah,
Yes,
yeah. Please. Share the screen, and hopefully everything's going to work out fine now for your presentation.
I'll share my screen.
Because maybe in the meantime, Nicole can check her connection, and we'll move on to the next presentation.
Okay, can you see my screen?
Yeah, all good. Thanks.
Yep. Okay. Yeah, so my name is Claire Johnson. I am a customer training coordinator at SciBite. I'm hearing quite a lot of noise in the background, actually.
Because try now.
I'm also going to switch my camera off as well to save bandwidth. Okay, great. Yeah, so hello, I'm Claire Johnson. I am customer training coordinator at SciBite. So SciBite is a text analytics and semantic enrichment software company. It was built by scientists for scientists. We have more than 10 years experience in helping customers improve the quality of their data. We have specialists in ontologies. Oh, hello, I can hear background noise again. Yeah, I think someone, Nicole, I think you have your, yeah, okay, I think that's better. So yes, we have specialists in ontologies, semantic technology, and data science. So our customer base is primarily in the life sciences, and we have many from major pharmaceutical companies. But we also work in adjacent spaces as well, including recently with a metals and catalyst company. So I just need to, okay. I need to get my slides, don't I? Okay. So SciBite takes, can I just check you can still see my slides?
Yes, we can still see the
Okay,
slide.
okay. So I just switched view. So SciBite takes a data-centric approach. So data should be every organization's primary asset. The data-centric refers to an architecture in which data is a primary and a permanent asset. And it's not tied to specific applications. We work on the FAIR principles, which obviously has come up a lot over today's sessions. Then we can be confident data can be consumed by a variety of different applications now and into the future. To do this, we must utilize some type of standards, such as the ones provided by Ontologies. So SciBite has a suite of tools in its Semantic platform to support customers to implement a data-centric approach and bring the most value out of its data. So rather than describe kind of every capability that SciBite has, I'm going to illustrate how we've worked with a company, kind of, I think, quite relevant to the audience for this workshop. And that was a company in the advanced metals chemistry and catalyst technology space, and how we have helped them to use technologies to unlock the potential of their data. So scientific data takes many forms and sources, including from publicly available sources, then from paid content providers such as full text peer-reviewed research, and thirdly, internal data. So a company's or organization's own data, which can include a really wide spectrum of different sources and types of data. And there's obviously a huge amount of knowledge wrapped up from all these sources. So the company we work with had a lot of internal data, particularly in their legacy electronic lab notebook, and it contained key experimental data from across the company. So that ELN application that was being used also due to be migrated. The data within it was not standardized, so it wasn't accessible for comprehensive data retrieval and data mining. So at SciBite, we use and build upon publicly available standard ontologies, and our curators comprehensively create and augment them to serve say primarily our life science customer base. So for the metals and catalysts company, we needed to build new ontologies bespoke for the company. So we applied AI techniques across a set of their documentation, so relevant terms were extracted, and then within SciBite's ontology management platform, which is called Sentry, our creators brought in existing public ontologies from relevant domains and augmented them to reflect the terms and vocabularies used within the company. So for example, company-specific equipment, specific processes in chemistry and manufacturing, and company-specific products. So these controlled vocabularies we describe as vocabs in SciBite. They apply an explicit, unique meaning and description to scientific terms. So, using our so if we take, sorry, so these standard and customer-specific vocabs were used to perform semantic search within our search platform, which is called SciBite Search. And SciBite Search enables a researcher to find all the relevant data and documentation, regardless of which term is used. So to take a life science example, if you were searching for documents or data on mouse, it would also search for synonyms such as mice, mus musculus, etc. And similarly for the company we were doing this particular work for, if you used the term, or search for the term catalyst, it would also search on those synonyms without having to type in every possible synonym or slight variation of that search term. Okay, so these custom vocabularies and SciBite search enable the company to find all the relevant documentation data, regardless of how specific terms they wanted to search on. And it really unlocked that data, and they're able to find it and use it. So this significant kind of added value of using technologies was recognized within that company. So they actually decided then to also take a license to Sentry, so that they can now manage their own company-wide ontologies and serve them to whichever applications they choose within the company. And they can update and edit as the different domains progress. And one key feature is Sentry is being built for ontology experts and non-experts alike. So subject matter experts can contribute to the ongoing development of ontologies without needing to be ontology experts. So with Sentry at the heart, they can now apply ontologies as data is created, not just the retrospective data, and they can search for this in SciBite. So hopefully that just gives you a little flavour of what SciBite can do. Okay, so if I kind of move on to more the customer training. So at SciBite, we have an ongoing commitment to train our customers. And this ensures SciBite customers can understand fully what our tools do, understand the value that our tools can bring to their field of work, and they can confidently use the full breadth of features and functionality of the tools. So think about who are our learners. So we have more than 35 organisations who hold licenses for our software, and each of them have different aims, needs, data architectures. Within them, those learners, they're professionals, mainly from industry, but some from academia and non-profit organisations as well. But regardless, they are busy. They have multiple pools on their time and attention, and they have a variety of specialisms and come from different subject matter experts, all really quite diverse. So what are their learning needs? So it means that they need training that is just in time, so exactly when they need these additional skills. That training needs to be accessed in working hours, and the skills that they develop need to align with their organisational goals. So then further, kind of how can the training that we deliver be designed to fit those needs? So it should be short and efficient. They'll be able to access it when and where convenient to them, and the training content needs to be specific to their organisation's use case, how they want to use it, and also tailored to the different experts and domains across their organisation. So we take a two-pronged approach to training delivery. So we deliver live customer-specific training, so just for that organisation. That generally takes place online using something like Zoom or Teams, but occasionally we do go to some customers and train them face-to-face. And then the second component is an online training portal that's called SciBite Academy. So a little bit more about SciBite Academy. So it has training courses that help our users train on the software platforms that they license. And then if we have delivered live training to them online and with their permission, the recording we can also put in SciBite Academy as well, in a space that only they can access. So the idea is that the learner can self-select courses according to what their needs are at whatever time they want to do. The courses are at different levels, from beginner to advanced, and also courses for specific user roles. And they can start and stop and take these courses at any time. So putting this into kind of reality, how we actually deliver the program. So when a customer signs a new license, then we will first give them access to SciBite Academy, and we invite and encourage them to go and start taking the kind of beginner introductory level training, so that they can get familiar with what the tools are and what they do. So just kind of focusing again on the Sentry, one aspect we're kind of always very aware of is just the varied understanding and misunderstanding of the field of ontologies as well. So quite a lot of our user base, they kind of know the term ontology, but they don't necessarily really fully understand what that means and what that means to them. So we do have an introduction to ontologies lesson, which we encourage users to take, to hopefully start from a common understanding, but it is actually an ongoing issue. So the next stage is to follow up with the customer specific live session. So it generally starts with introductory overview, how to use the main features and functionality, and it's tailored specific to that organization, how they need to use the tools that they have. And in that training session, there's usually a mix of different professionals and subject matter experts with different roles in the organization. So as I said, there'll be both experts and those unfamiliar in the field of ontology, so the training needs to meet the needs of both. So where we've delivered those online, say it generally is delivered online, and we record them. We make that recording available in SciBite Academy. So following the live training session, they can go back and they can review any parts of that training session, maybe focus in on some details they didn't quite pick up the first time, just refamiliarize themselves, any aspects they didn't get. And also anybody who couldn't make the session as well, they can then access all that training material. So it's actually a particularly useful resource. And then following that, we encourage the users to follow up with any other more kind of role-specific training, or perhaps more intermediate level training in SciBite Academy. And then if it's needed, we can follow on again with further customized training. So perhaps deeper dives into certain aspects, or specialisms that might be quite niche or specific to their use case. So we'll do some further live training. So from this, we should have created our software superheroes. And also we find that they can be advocates for the use of ontologies and semantic technology within their organizations. So that's our approach. So I want to move on to the challenges that we face. So one of the biggest ones is actually getting people to train, kind of take up our offering of the training sessions that are online within SciBite Academy. So we often see a slow uptake on that, and I think it's kind of partly kind of like, you know, I'm doing my job fine, why should I do it? Why should I do it differently? There's a lot of training that happens in organizations, and you know, unless you're really forced to do it, people don't want to take another training course. And there's also a lot of kind of, well, I'll just use the tool and I'll work out how to use it myself. And generally there's a lot of intuitive things within the tooling. But obviously there's a lot more complexities and features and functionality that perhaps they wouldn't find automatically. So we're looking within SciBite at the moment how we can increase the uptake of, I say, it's mainly the on-demand training. So we have learning objectives for courses, but trying to measure whether those objectives were met is an ongoing challenging. We're not going to contest these professionals, but it is a challenge to know if they can actually do what we set out to train them to do. We sometimes do exercises as well. but to say overall, it can be difficult to actually know they've gained those skills. And also thinking about what was the learner's experience as well. Did the training meet their expectations? Did we deliver that? So we're starting to collect feedback as well from our trainees to further enhance our training courses. And then thinking about how those learners get recognition for those new skills that they have developed. So we don't have any formal recognition process. Obviously, it would be probably quite useful to have recognition, say, with your employer as well, that you have gained those new skills. So we're looking into that. And then finally, the last one is actually a really big one, and I'm hoping to draw on some of the experience from the community here. So from our customer base, we constantly have a lot of questions about ontologies, from what is an ontology, completely not knowing what it is, to actually thinking they know what it is, but having quite a lot of misunderstandings about it, to the extent that we've even heard from customers that within their organization, they've even stopped using the word ontology because they find it confuses so many people. It's actually not helpful, so they're even trying to avoid it. But I don't think we kind of should try to necessarily avoid it as well. And also trying to show the value of ontologies as well. All these things are not necessarily kind of easy things to convey. Together with one of our partners, a company called Ziffo, we're in the process of creating a short animation, which we hope you will help. But really kind of, I want to throw out questions to this audience as well is, do you face this issue as well? Do you have any tips and advice? Are there any resources that you think might be useful to share as well? Perhaps any success stories where you've been able to overcome resistance to using ontologies. Okay, so thanks for your attention. If you have any questions, if you want to get in touch after the presentation as well, anything that I've touched on, then please do. Thank you very much.
Thank you. Thank you so much. Yeah, very good questions. And I kind of would say they feel familiar to us.
Okay.
Let's say more on the question than on the answer side. We have a prototyping lab running here during this event as well, with some interesting cases, and we have these demonstrators in the OntoCommons project that are kind of showcasing ontologies in use in various companies. But I'm sure you have a lot of these types of success examples as well, and nevertheless face the issue. Anyway, before we start a long discussion on that, which we hopefully can still have or have another time, I would like to give a chance again to Nicole to see whether we can sort out the issues and I will mute myself.
Okay, how's this sound? I think it sounds better. Can everyone see my screen okay? Can you hear me?
Yep.
Okay, good. Yes. I'm Nicole Vasilevsky. I'm the Associate Director of Data Science at the Critical Path Institute, which is a nonprofit based in Tucson, Arizona that uses semantic technologies to help advance drug development. And I am based in Portland, Oregon. I work remotely to this institution. And I'm going to share some work we did on a resource called the OBO Academy, which provides freely available online training materials for biontologists and semantic engineers. So during this talk, I'll give you an overview of the OBO Academy, which is a collection of training materials, including tutorials and how-to guides. So I'll talk about our approach that we used to develop this content and how we disseminated these materials. And I'll describe the content that we currently have available. I will talk about the different target audience and how folks can contribute to this effort, and how you can use these methods to develop similar open training materials for your community. So the goal of these materials that we developed is to consolidate knowledge and best practices on open biomedical and biological ontology development and semantic engineering. So like I mentioned, the OBO Academy is this collection of online training materials that they're completely open and publicly available to anybody. The materials are intended to be self-paced and intended to cover all aspects of ontology development and ontology curation. So the content is available on a MakeDocs website, and the content is hosted on a GitHub repository, which is called OBOK, which stands for the Open Biological and Biomedical Ontologies Organized Knowledge. So anybody can go onto the website and view the materials, and you can also click through the website to the GitHub repository where you can actually see the development of the materials, and you can edit it and make pull requests and contribute to it as well. So the goal of creating this resource initially was to kind of take all the siloed knowledge that we had from the various ontologies projects that we've all been working on and create a consolidated place where we put all this material into one single resource. And this project was initially developed based on funding from CPATH, where I currently work, where I didn't work at the time. I was hired as a consultant along with several of my colleagues to develop training materials specifically to train some ontology engineers at CPATH. So this is a really interesting example of a public-private partnership where CPATH funded us to develop these materials specifically for professional development reasons. And then once we finished the training that we needed to do for their employees, who are now my coworkers, they allowed us to make the materials publicly available and open to the community. So hence we created this website called the OBO Academy and shared all the resources that we had developed and took all the other training materials that we had from various other projects. And now we have this as a consolidated resource for the materials for our community. So this was initially created by a group of us who were mentioned on the title slide, but the intention is not for these to be owned by us. The intention is for these resources to be a community resource and to be available for anybody to use, anybody to contribute to, anybody to adopt and use for their own purposes. So I would encourage all of you to look at these resources and using the training materials that are relevant to you. You can contribute to them, you can adopt them and use them elsewhere. They're fairly open and available for anyone to use. So the material in here is developed under the guiding principles of the OBO Foundry. So I'm not sure if your community is very familiar with the OBO Foundry. It's a community of ontology developers in biological and biomedical ontologies who are committed to developing ontologies under a shared set of principles. But some of these include making ontologies that are open, that are publicly available, community-driven. The ontologies are built to be interoperable with each other. So we like Henry had mentioned the BFO, upper level ontology. So we try to use some similar upper level ontologies to make the ontologies more interoperable with each other. And also one of the other principles is to ensure that they're scientifically accurate. So a lot of the content that's in the OBO Academy resource documents these best practices that come out of the OBO Foundry and adheres to these basic principles. So yeah, just to emphasize our goal, the purpose of the OBO Foundry is to capture the collective knowledge from these different resources into the single source of documented knowledge. And so one can go in here and learn ontology development. And this resource is meant to apply to a broad audience across different skill levels. So it could be from anyone who's just beginning to learn ontologies, who's never used ontologies before, anyone for more advanced people who are software engineers or semantic engineers who want to learn more advanced workflows. There's content in there that really applies to anybody. So I've been working on ontologies for a long time, but there's a lot of content in there that's still relevant to me to learn. Also, and it's also targeted to ontology contributors, so people who are using ontologies and annotations who may not be developing the ontologies themselves, but there's training material on how to make term requests and how to use ontologies for curation and such. So, so yeah, we hope that with this material, we can train a vast range of users and also help them learn how to contribute to ontologies and break down the fear of contributing or using ontologies and feeling like we would like them to feel like they're part of this community. So some of the available content, I'll share with you what we have available. So first, I want to emphasize that the content that we created in here in the OBO Academy is built on this diataxis framework. So it's divided up into 4 different kind of axes of classification. So we have tutorials, which are basically the lessons that we have, which contain kind of step-by-step instructions on how to do certain topics, and they include like exercises and things that interactive activities for the users to do. And like I said before, it's intended to be self-paced. So the content is meant to be descriptive enough that somebody could go in and just do the tutorials on their own. And I should also mention that these materials are iteratively developed and they'll be always continuously developed. So a lot of the lessons are more or less done. There's a maturity status on the page that kind of indicates how far along it is, but there may be some issues or incompleteness that could be noted in some of the lessons. And like we said, it's a community resource, so we hope that if anybody notices any errors or typos or inconsistencies, that they would go in and either report the issues or go in and make pull requests to make the changes themselves. So we have the lessons and tutorials, and then we also have how-to guides, which include things like specific task-oriented guides, like things like how to set up protege or how to add a new term to an ontology or how to make a term request, things like that. We also have reference guides, which are more information-oriented documentation, and then explanations, which help try to clarify, deepen understanding of certain topic areas. So the lessons that we currently have in OBO Foundry are listed here, and I won't go into detail about all of these, but just to note that these are the lessons that are currently considered more or less complete or mature. We also have several lessons that are under development, and we also encourage people to create their own lessons and add them to the repository or request lessons, and we'd be happy to try to recruit someone who's appropriate to develop material and can even present it as well if needed. We also offer different pathways for learners too. So if someone's an ontology curator, some specific lessons may be most relevant for them to learn, or someone's a semantic engineer or more on the technological side, we have specific lessons that we recommend for pursuing. So thinking about how we chose the content, it really was kind of the content was selected via many different reasons. So initially, since we were funded by CPATH to develop these materials, we worked with them to develop specific training materials that suited the need of the CPATH employees and that team. And then as we went on, as after we completed that project and made the materials publicly available, we actually started offering bi-weekly training sessions with members of the Monarch Initiative, which is a consortium that I'm part of, and my colleagues are as well. So we have specific training materials that we've developed for the Monarch Initiative training based on our specific training needs amongst our team members and based on requests from our specific team members. And then we've also had a lot of existing content that kind of existed from different ontology development teams, like the cell ontology team had some really well-documented content and such. So we aggregated what we kind of had to kind of take away all the siloed materials and put them into this one single resource. And then we also have the mechanism to have users request specific training topics. And they provided a link there at the bottom. So if anyone has anything that they'd like to see on the OBO Academy, you can add to the discussion at that link below, or you can also upvote or downvote topics that other people have requested. So here's some examples of what the content actually looks like. So this is an example of the landing page. So this is built using Make Docs, and this is kind of the format that is displayed. I think one of the big advantages of using Make Docs is that it has a really good search interface. So if you go to the search bar, you can search for any of the content in there. Also, it shows the table of contents on the right, so you can click through the specific content in this page, or then the left-hand sidebar also has different kinds of content, so you can navigate through the site very easily. And here's some example of a specific lesson. So this is a lesson on contributing to ontology. So this is one of the more basic lessons on this kind of initial getting into ontology development. So we try to structure the lessons in a similar format with prerequisites, necessary preparation, giving an overview of a description of what's delivered and the learning objectives. And in each lesson, we track who's contributed to the lesson. So in this particular lesson, these materials have been developed and aggregated over many years by many different contributors. And some of these original contributors created this material over 10 years ago, and the material has been iterated upon and developed over the years. So we try to capture all the provenance and give proper attribution to anyone who has contributed to these materials. And like I said, this is a community resource. So if you wanted to contribute to it, we welcome you to add your name to this list. And so we have detailed instructions in the lessons that you can go through and do kind of step-by-step instructions. And some of the lessons include interactive exercises that you can go through to guide your understanding of the material. So the material is really intended for anybody. This is an example of the kind of some different roles that folks may have who contribute to semantic engineering, but really it's not exclusive or exhaustive, and people may perform in more than one of these roles simultaneously. And I won't go into too many details about the specifics of what these different roles are, but just know that the material is really trying to be broad sweeping and to apply to a wide range of audiences. So it could be curators or ontology engineers or software engineers. So anyone who's working or using ontologies, we hope that some of this material will be relevant for you. And what do the trainees do with our OBO ontology training, OBO Academy training? So a lot of the trainees are, we have the people that we've worked with in person. We don't know everybody that's used materials, but like I said, we initially trained some team members at the CPAF Institute, and they are ontology and standards and metadata engineers. We've trained a lot of ontology curators who are the ones who are going into the ontology and adding new terms and classifying terms. We've trained a lot of ontology engineer and developers who are kind of developing the ontology workflows, like doing the releases or managing pipelines and such. And also we've targeted our materials towards ontology contributors too. So anyone who's using ontologies for annotations or making new term requests or asking for changes to the ontology, just to empower them to ensure that they understand how these ontology workflows work. And with regard to how long it takes to get the materials, it's really difficult to say kind of, if you wanted to go through all of the materials, it'd probably take, I would probably guess to need a full 40-hour work week or so. The lessons vary in length, and we've been doing these online bi-weekly training tutorials with the members of the Monarch Initiative, and we record a lot of those sessions. So there's these 1 hour long recorded sessions that one can listen to, but then also a lot of the material is just self-paced and you can go through it at your own pace. So the time investment is kind of difficult to say. It just kind of depends on which material you want to use. And also there's the ability to kind of pick and choose what's most relevant to you too. So to become a full ontology engineer would probably take a lifetime. I wouldn't even say that I've been anywhere close to that myself. So it's kind of hard to say how long the material will take, but there's varying lengths, and you can kind of a la carte pick what you need. So so just to wrap up, I'd like to thank you all for listening, and I'm glad that you, thank you for the opportunity to talk about this resource that we've developed, and I hope that this is useful to you. I hope you all check out our website, and we really encourage everyone to go in and contribute to the materials as well. And we've worked with a really fantastic team of people. These are some of the folks who contribute to the initial development of the material, but we have a lot of contributors who continue to contribute and help with this effort. And in particular, I'd like to thank Nico Matenzoglu, who's been particularly exceptional and has been leading us in this effort. And thank you. My contact information.
Thank you. Thank you very much. Wonderful. Thanks again to all our contributors. I think what we have seen today is, I mean, we hopefully have a few minutes. I think we're running a little late.
No, but we can wrap up the day. We don't need to. My impression is, I mean, we've had this very nice sort of arc in a way from, the training of the students, the next generation. But, kind of a takeaway is that some of the semantic engineering training is maybe at a higher level, master's level, where a lot of people have already left, even if they studied data science, or it will maybe start more to become more of a topic in the future. But current workforce, if you want to use that term, maybe even if they have data science, don't have a lot of familiarity with this subject. Then we have, of course, the different, we've seen the different communities. Of course, we, use of ontologies for the domain experts. So I think that was the Fairlight project example, but also I guess is what Claire is dealing with here and has told us about. And then, of course, the people that actually do design the semantic engineering, right? As you said, I think Nicole is like a lifetime thing in itself, to be more and more proficient in that. I think that these were really all great, sort of the elements, all of the things, all of the components of that ecosystem, I think came into play here, which is great. Questions, and of course, maybe you also have questions to each other, which you already raised, and please go ahead. If we look at now the use of these tools for the non-experts, what is the things that we have here, especially if I compare the experience from an open source project that used a lot of the available tools, but at the same time, so I think had a lot of challenges maybe that you wouldn't have had if you had the SciByte software stack. On the other hand, it seemed like the people you're working with, Henriette, they were very keen to reap the benefits, right? Maybe more keen than some of the people that use the professional tools in the company. So we've got this sort of, some things work really well on this side, and others maybe work better on the other side. And how can we combine that and increase the benefits? I mean, okay, this was a lot of rambling from my side.
If I can maybe. Can you hear me?
Yeah, go ahead.
So if I maybe can comment. I like your cat. I think I suppose the most valuable lesson for me was to allow the people that you teach the opportunity to ramp up. So a slower progression. So I said that there's all these tools that I end up dropping out and keep it as simple as possible to start with. I don't think that is how it's going to end. I think all the tools that I've intended to use is going to become important, but introduce it gradually. You don't have to start with everything on day one. And I think that allows people that that incremental gearing up. So I don't think one should underestimate the effort that people have to go through to make this mental switch, because it is a sort of a paradigm shift. If you have not been exposed to ontologies beforehand.
So it seems, however, through that process there is then a kind of a kind of taking ownership, right? Which is a motivating factor in itself. Yeah. Claire, do you want to comment on that, or any thoughts on that?
Well, I was just going to say I agree about that paradigm shift. That's where we need to get quite a lot of our users for. So, we have the split where there are people who really do understand it, and they're the ones who are going to be developing the ontologies. But it's then how that's spread into their organisations. Those are the ones. And often it's the budget holders as well who don't quite understand the value it's going to bring to actually get make them understand and show them the value of it. So if we somehow get that paradigm shift to those kind of more non-users, or not direct users, that would be, absolutely, so valuable, I think. So anything anyone can share would be brilliant.
That is where I think what is also very valuable is to be able to figure out that little small first step that you can take that can show a little bit of value. Now, at this stage, I don't think in what we've done in our project shown any value as yet, but at least it helped people to start to see how this could work. So I think that first little thing that you can do that shows value. You don't have to eat the elephant. You just need to take a little bite.
Thank you. Are there any questions from here, or comments from the other speakers from the audience? No, that's not the case. I had another. Yeah, I mean, on the tools that you're using, Henriette. Well, okay, maybe this is a very specific question, but from me, did you also use or try and use Web Protégé as a tool to use, a semantic tool, but that is more collaborative, doesn't rely on installing it and so on. And maybe also see that as an example. I mean, we have had projects where we also ended up, or we actually running a project at the moment, ending up with spreadsheets. Where we have I mean, that looked so familiar to me when you showed that. But we're also then trying to move again from that into Web Protégé, because people can't use anything else in the middle. So
okay, so I haven't really used Web Protégé, and I'm not really aware that, for instance, in EBI, we're not using it, and I'm also not sure that in the web community it's really used. I know, Nicole, you guys also don't really use it.
No, we use the desktop version, but I worked with a group who was using Web Protégé as their primary tool, and I was like, come on, use the desktop version. This is what we all use. But
yeah, so when I started with these people, it was just Celine that I've worked with. And at that point, there wasn't a need for sharing or collaboration. So that's why I started with Web Protégé, with Desktop Protégé. It might be, but my impression was that in terms of the expressivity of your ontologies, there's some limitations around Web Protégé, but I might be wrong. So.
So this is not, I was not talking about it using really in terms of its capabilities, in terms of expressivity and so on, but simply as a tool which is collaborative. You can work on definitions and so on, but already you can start to expose a little bit more of semantic technology within that, a bit more gradually, and also you can then more easily convert it rather than having a converter from spreadsheet to OWL and all of this sort of business. Yeah. Anyway,
have you used it yourself?
Yeah, we're using that.
Okay.
But anyway, we're getting too specific here maybe, but I mean, it's just an example of the sort of, I mean, I'm not saying, we've got this at all sorted, but it's a sort of trying out different things, it's more along those lines. What is often very time consuming with the in terms of training to get to a result in reasonable time, this is the spreadsheets and the terminologies and vocabularies and definitions and so on. Claire, what is your experience? I mean, is it, of course, you're offering now professional tools, okay? Maybe this is expensive, but nevertheless, it would be interesting to understand to what extent, this can be, streamlined a lot by using software such as SciByte.
Yeah, I think it does streamline it a lot, because you don't need to be, let's say, an expert in it, and it is a collaborative tool as well. So different people can go in to suggest things, and but there's still then people who take control of that. But it is meant to be kind of very user friendly and collaborative from that form. So you don't have to learn kind of a lot of things for that.
Because it's good to see and good to know. I mean, even okay, this is kind of a typical maturity development as well, I think, which we're kind of lacking and seeing maybe with the onset of such tools in a professional environment with commercial licensing, but typically also some of these capabilities will become available in maybe more widely accessible tools in the future. I'm not taking away as your business probably also will mature into other areas. It's simply mature.
Yeah, and also it's driven by what our customers want to be able to do. As it's developed further and further, it's the capabilities that they need. We're putting into the tool and further developing it, so it's driven by the users.
So there's a question here from Florina.
Not a question.
Or comment.
So I think they can
join us. It's nice that you join us.
Yeah, I think it's better. So thank you very much for the presentations. And my question, or just actually I would like a confirmation from you. So the tools you presented and the material, they look to me very much like very hands-on. So that there is a lot of manual work where you have to type every word inside and check and double check and so on. And of course, this is very tedious for lots of people. And I can understand the question. Yeah, why should I do it? What's this bringing? Are you aware of any automated tools that would maybe help you a little bit to know, fill in the spots, fill in the templates and so on in some automated way, some like language processing? You give it a document and then it will just parse, you give you the words and then propose you. This would be maybe one way to encourage more people to use it. The reason I'm asking is that any data science student would go away from any field like this because it's not interesting enough. They are not. There is nothing to program. There is only just typing in data.
One of the OBO tools that's offered is called Robot, which is a templated format that can script in ontology terms into the OWL format, so that accelerates the addition of terms into an ontology more quickly.
So I didn't acoustically. Yeah.
No,
could you not hear?
It's a lot of manually typing in. It's a lot of manually typing in. Yeah. So I did play with Protégé. So that's why I would ask you, because we in one of the projects we used it. We didn't like it because I don't have the time to type in everything. So I tried to find some other automated tools, and there were none, at least in the area I was looking on. And maybe there are some in your area.
Yeah, Robot is an option. I put it in the chat. I don't know if you can see that. It's a spreadsheet-based template that you can script in terms and bypass using Protégé.
Okay. So,
okay.
Yeah.
Thank you. Yeah. Okay. There we got it. Yes. Thank you. There is a comment. A question. So relevant to the session topic and to the pedagogy is this project. Okay. There's an ontology guidebook mentioned. That provides content. I started offline as a student in 2011. Contact me to discuss. Thank you very much for this intervention as well. We'll work that into also the output and outcome of this session. So what we are aiming is, of course, this will be input to the updates of the roadmap and also to the final version of what we have in the area of the knowledge management translator, where we're collecting these resources. So we will get, and Alex as well, get back in touch with you also to follow up on that. Yeah, thank you very much, Robert. And with that, I would like to then conclude the session. Thank you all for your presentations and contributions, which are very much appreciated. And thanks to everyone online and here also in the audience.
Thanks so much.
Thank you. Thank you.
Thank you, Gerard. Thank you, everyone, all the speakers. I think we can wrap up the day for today, given also the delay with the time. We won't do the summary of the sessions, but we wait for you tomorrow at 9:30 with a full day dedicated to industry. And we'll start with a session on domain interoperability. Tomorrow we won't have separate parallel session aside from the prototyping lab, which is still going on here in Oslo and online, and we will see the results of this on day 4 innovation. Thanks all for your patience today and for being here. We are really happy that you followed us through the day.